Hello everyone, welcome to our first video, which is an introduction to time series analysis with a special emphasis on business. Okay, so what we're going to cover in this lecture is first the definition of a time series, how this data structure is different to observational data when we were using regression models or classification models. Then we're going to discuss why these time series are really important in the industry for demand planning and the sales and operations planning process. And finally, we will go over some of the forecasting methods that will be covered in this course. Okay, so the first definition is what is a time series. So pretty much it's just a sequence of observations. And here it is important the order of the variable. In previous analysis, when we're talking about regression models, classification models, the order of our data does not matter. So typically in supervised learning, you were given some x variables, x1 up to xk, and then one or multiple dependent variables. And in each row, you have your observations from 1 to n. Well, in those studies, the order here of these rows is not relevant. If you change it, you get the same result. It's not a problem. But in time series, that's not possible because our observations are indexed based on time or of when that observation was recorded. So it is important. So we use different notation. Zeta t refers to the variable, right? You will use like lowercase zeta t to represent a specific value. Okay, now there are some assumptions because real life is more complex than like just the models. In time series, let me give you an example. If you're analyzing stock market, let's say that you're just looking at the Google stock or Apple stock, or let's say Nvidia, which is like one of the biggest companies in the stock market. So if you see Nvidia, let's say that we are focusing on the stock value per day. So there is a key assumption because, okay, you have the value, on Monday, Tuesday, Wednesday, Thursday, and Friday. But then during the weekend, the stock market does not operate, right? So we will get a new observation next week. So typically, like during weekdays, the distance between one observation and the other is just one day. But from Friday to Monday, the distance is not one day, right? But we make an assumption, of course, that they're equally separated, right? When we assume that time is a discrete index here. Another example of the complexities when we're dealing with time series and some of the assumptions that we make. For companies, it's important to make a forecast, of the demand or the sales, for the different products or different categories that they have. So let's say that we're analyzing our demand per month. So an assumption here is like all months are the same, but they are not because the number of days is not the same, the number of business days is not the same, right? So, but we assume, right? We just create an index like month 1, 2, 3, and we assume that they are equally, like separated, or the distance between one month and the other is the same. But in reality, is not, right? But again, those are just some of the assumptions that we need to do because otherwise, then the complexity will increase. Okay, so what is the key idea when we have time series? The main objective is first we want to understand the structure of the time series. Like we want to analyze what is the pattern that it has, whether it's constant, if there is a trend like a positive or negative trend, if it has some seasonalities or a mix of all of these components, right? Because once you understand the behavior of your time series, then the next goal is to make predictions, right? Is to make a forecast. So those are the two key central objectives. So in this presentation, we'll discuss different methods, just like a brief introduction of the methods that we're going to use for that. But it is important to emphasize that before you start applying the methods, you need to visualize your time series. It's like you can call it like a exploratory analysis. You need to plot, right? You need to understand. You need to see before you start, like deploying some models. Okay, so why time series are important? Pretty much because they are everywhere, especially in the industry, like private and public companies. They use time series all the time. If you go to the private industry, in businesses, they need to make forecasts about the sales of next month, next quarter. It is important for the planning, as I will show you in a couple of slides. In the public sector, it's very common to see like demographics or also some key metrics like inflation rates, unemployment rates. So typically we visualize these time series because they are important, for the general public. In healthcare and public, I remember during the pandemic, during the COVID-19, many years ago, uh, it was very common, like, all news were sharing these time series, using visualization so people can see what is the pattern, right? To see if it was increasing, decreasing. So it was relevant, right, to know how to analyze time series with this type of information. So the key components of a time series, so we have the trend. So people typically will try to make sense of the trends as the slope, if it's like a positive slope or negative slope, but the trend is a little bit more general term because it's not just a slope. It can be you can model that with a polynomial expression, but it shows like if the time series is increasing or decreasing. The seasonality. So some time series they have patterns that repeat per month, per quarter. Just to give you some examples, think about school supplies. So if we analyze like the sales per month, you know that there are some months of the year where we will have some peaks, right? Because it's like, right before kids are going to school, so parents are going to buy more school supplies. So that can be July, August, right? So you will see some peaks in the sales of that specific product. Now it's not just for products. Also, if you think about services, you can say that, for example, reservations for air travel or also for hotels, Airbnbs, or similar services, they experience seasonalities, right? So in some specific months of the year, they have peaks, or there are other specific months where they have low demand, right? So that's a seasonality. So it's a pattern that repeats consistently every single cycle. Like in this case, cycle will per year. So every year we'll see the same behavior. It doesn't mean that you have to get the same values. It's the same behavior. It means that the peak, you will experience the peak in the same time. It doesn't mean that the peak it has to be exactly the same value. Here we're talking about the pattern, right? So that's seasonalities. Sometimes we have also technical components which won't be covered in this course. It's not the nature of our analysis, but in real life, especially in the economy, there are some cyclical components that you will see every 5, 10 years or more. So they are beyond the scope of this course. We will focus more in things that will happen per month, per quarter, like within a year. And of course, as every single predictive model, we always consider an error or an uncertainty parameter in our model, which reflects that you cannot, like there are some things that we cannot understand, we cannot capture, but typically we expect that this error has a mean equal to zero, that it's independent. That's very important, not just for time series. It's like in every single predictive model that you have created before, when you analyze residuals, we want them to be pure randomness. You don't want to find patterns in the residuals, in the errors, because if there are patterns in the errors, that means that your model is not capturing those patterns. So that's a problem in your model. Okay, so there are three key elements of forecast, or three key characteristics that it's important that you should be aware of them. So the first one, it's like they are always wrong. Your forecast, they are always wrong. There is always an error. You have to be aware of that. And of course, our objective is to minimize that error. But there will be always an error. It's important to be aware of that. So our key idea in general is to minimize there are different metrics. So we will use typically like the mean square error, similar to regression models, but also in forecast, when we're dealing with time series, we use what we call the MAPE. It's the mean absolute percentage error. So it's just, like your error measured as a percentage. So if it's 5%, it means that your prediction, it's 5% off the real value. Okay, so first characteristics, they are always wrong. Your forecasts are they are always wrong. There will be always an error. The second one is that shorter time horizons yield more accurate forecasts than distant ones. So let me give you an easy example here. Imagine that I ask you, do you think it's gonna rain or in the next 2 hours? So for you to answer that question, so I'm sure that you will, like look through your window, or maybe you will go outside where you are located to see the sky, right? See if it looks like it's gonna rain or not. So based on that information, you can, make a prediction if it's gonna rain or not in the next 2 hours. But what if I ask you, is it gonna rain in 6 months? You don't have, like it's impossible to make that prediction at least for now. So the key idea here is that if whatever you're going to predict is close to where you are in terms of time, then you're going to be more accurate when you instead of when you try to predict something that is going to happen in a longer time horizon. So even in sports, you can think about your favorite team in your favorite sport. So if I ask you, do you think your team is gonna perform well next weekend? So you can make a decent prediction, right? Because based on the performance of recent games. But if I ask you how your team is gonna perform in 1 year, for you it's going to be more difficult to make that prediction, because there will be maybe different players, there might be some injuries, and all the things that can happen and affect the performance of a team. So that's our second key characteristic. And the third one is really important, and maybe at the beginning it's not that simple to grasp this idea, but it says that aggregated forecasts are more accurate than disaggregated ones. So what is the meaning of that? It means that if you try, let's say that you have like products, like items. So item one, two, and three. Three products. Mind that they belong to the same category. It's like they are soft drinks. They are just different flavors, different SKUs, different products. So the third characteristic means that if you try to forecast each product, each time series individually, then you're going to be less accurate. Compare that if you try to make a forecast of these three products aggregated. It means that if I have like the category of these soft drinks, it's the category. So you will be more accurate if you analyze the category instead of the individual products. So that's not just in terms of products, that also means in terms of regions. So it's easier to make a prediction of like whole city compared to an individual store. Same idea with time. You can also aggregate time. So if you try to make a prediction for a product per hour, that's very difficult because like if you analyze the time series per hour, you have a lot of zeros maybe depending on the product, and then maybe some sales. But it's difficult to it's gonna have a lot of noise, that time series, if it's per hour. Now if you aggregate, and instead of hours, let's say you go to months, then it's different. You will be able to capture the pattern in an easier way. So that's the whole idea about aggregated forecast. And this is a key principle when you are forecasting time series. Let me give you a example with numbers, because I know that maybe this is not intuitive. So let me give you an example with numbers. I'm gonna open Excel real quick. So we make our example here. Okay, now you can see. So let's say that we have 3 products, right? So we have item 1, 2, and 3. You can think about any product that you like. So let's say that we have the mean value of the sales. This can be per month, it doesn't matter. So we have the standard deviation. So I'm going to assume it's the same. It's like 100 units, 100 units, 100 units per month. And this is the average for each product. For the standard deviation, I'm going to assume 10. I'm going to use the coefficient of variation. I'm going to calculate later. Okay, so this is the performance of my product individually. This is the demand, the mean value, and the standard deviation. Now let's say that I want to analyze the category. It means the 3 products aggregated. So for the mean value, it's just the sum of them. It's just the sum. So the sum is 300, right? Now, how are you going to find the standard deviation? I'm going to give you pause the video for a minute and try to guess how you're going to find the standard deviation of the category. Should I just add them up? The average of them? No. So for standard deviation, yeah, we cannot just add the standard deviation. You can add the variance, that's possible, but here we're getting the standard deviation. So therefore, this is the square root of these variances, the sum of these variances. Okay, we're almost done. So this is the standard deviation for the category. So it's just the square root of the sum of the variances. You cannot add up the standard deviation, but you can add the variances. It's a convolution of variables here. All right. So where do you have more uncertainty? When you look at the item level or at the category level? So if you look at the item level, you see a standard deviation of 10. When you look at the category level, you see a standard deviation of 17.32. But this is not a fair comparison because the mean values are not the same, right? It's 100, it's 300. So that's why we're going to compute the coefficient of variation, because this is a more fair metric here for the comparison. Is just the standard deviation divided by the mean value. So the nice thing about this is, like, when you divide standard deviation over the mean value, then you cancel the units. So there are no units now. And now we're measuring the standard deviation. It can be seen as the percentage of the mean value, right? So it's like 10%. So it's the same for the other products, but when you measure the coefficient of variation, you see that here we're cutting almost in half the coefficient of variation. So it means that in the case of the category, the uncertainty measured as the standard deviation, it's roughly 5% of the mean value, right? So it's less than the 10%. So here you have less uncertainty. So maybe this will give you a little bit more intuition, right? Uh, about the third principle that we were discussing. So let me go back to our presentation. This is our presentation. And we're talking about the aggregated forecasts are more accurate than disaggregated ones. Now, I just provided an example of why this happens. All right. So now let's go more from the industry perspective. Why forecasting is important. Imagine that all of us, like in this course, we want to create a company and we're going to sell a product. So the first question is, okay, if we're going to sell that product, okay, so how much do we need of our raw materials? How much do we need to procure for, of the different materials that we require to manufacture our product? And then how many units of that product we're gonna make, right? We're gonna manufacture how many units. So we need, in order to answer those questions, we need what we call demand planning. So we need forecasts about the demand of our products or the services, because with that information, then we can start planning, the inventory, the procurement, the manufacturing, even from the financial perspective, the finance area, they need that information so they can identify the amount of money, the resources that are required to be able to keep up with the operation of the company. So demand plan is critical. Time series analysis, it's key here because that's how we make a forecast, like for the demand planning process. So typically in companies, they have what is called the sales and operations planning process, S&OP. So the idea of this S&OP is to find a forecast that is aligned with all areas in the company. Pretty much like everyone is working towards the same number, because as I just mentioned, forecasts are required for every single area of the company. If you're talking about logistics and operations, they need a forecast. What is going to change is the units of the forecast. Because in the case of, like operations and logistics, they will need information about how many boxes, how many units, right, per product, because that's how they, that's how they use the information. Thinking about products, boxes, trucks, if we're talking about logistics. In the case of the marketing and sales, maybe they just look at money, same as finance. So everyone in the company will require some forecasts, but they are in different units, different aggregations too. So in the S&OP, the idea is to align all these areas, with the same numbers. Of course, in the units that they need the forecast, but it is important that they are made in the same process. A common error, especially in the past, is like every single area was finding their own forecast. And that was a problem because they were not aligned. Like they were working towards different numbers. So the idea of the S&OP is like, first, you define a baseline demand forecast. So this is based on historic information, like previous sales. Here, of course, you need to know like if it's going to be like new products, it's going to be like new promotional pricing plans. That's relevant here to make this baseline demand forecast. So this is the first step. Once you have like a baseline forecast, and to get this number, you will need the methods that you're going to learn in this course. But then remember that real life is different than like an Excel file. So in real life, there are constraints. There are constraints. As I'm recording this video, there is a war, in our world. An important passage for chips is affecting oil supplies, right? So that may affect, like some industries, of course. So that happens all the time, not worse. That I'm talking about constraints in general. They happen all the time. Sometimes you cannot control them. In other cases, there are those constraints are part of your company. Let's say that there is a machine that broke down. There was, I don't know, like a fire in one of your plants. There is some protest in the city where you live that is affecting the logistics. So there's some, like some constraints that affect your operation. So you need to bring down that forecast. You need to consider the constraints, right? And that's how you gain a constrained demand forecast, which is pretty much a plan that it's aligned with the reality of your company. But the first step was to find a forecast using time series analysis. Okay, here you have more information about the SNOP. This is important, guys, because even though we're working, on a master in data science and analytics, and maybe your focus is only on the methods, it is important to understand how whatever you're producing with your methods, how or who is going to use that and how is going to use those numbers. So it's important to be aware of the context where time series model work. Okay, so some important considerations when we analyze in time series, we check whether our time series is stationary or not. So just a basic definition, a time series will be considered stationary if the mean value and the standard deviation or variance are constant. If the mean and the standard deviation are constant for every single time interval that I take for my time series, then it's considered stationary. So stationary means in this context like stable, is not changing. So those are like the synonyms that you need to keep in mind. So it's like, mind like it's not increasing, it's not decreasing. There are not weird patterns. It's pretty much stable or moving around a specific level. So that's a series that is stationary. And non-stationary means the opposite. It means that whether the mean, the variance of both of them are changing. Like in this one, if I take two different time intervals, let's say this one and this one, the mean values are going to be different, right? So it's not stationary. Now, as I mentioned before in this video, the first step when you're going to analyze time series is to visualize them. So, but sometimes it's difficult to conclude that it's stationary. So there are some statistical tests, Dickey-Fuller, that's one of them, Dickey-Fuller, DF, and you will find packages in Python, R, to perform the Dickey-Fuller test. And of course, we will implement this test in upcoming lectures. So you know how to judge whether a time series is stationary or not. But again, visualization is the first step for sure. Now, the forecasting methods. So we will go over three different methodologies. You need to know all of them. They are really important. They are different. Actually, we can, when we're solving problems, we can make them compete. We can, like pick a subset of each methodology and then compare them. That's very common in data science. So first, we will go over smoothing methods. They are like some classical methods that are typically used in the industry. It's like a better version of the moving average. So we will go over the simple exponential smoothing, the double exponential smoothing, and the Winters method. So the simple is for stationary data, that time series. The double or the whole method is when you have trends, like increasing or decreasing trends. And when we have seasonalities, we will use the Winters method. Then the second group of methodologies will be ARIMA or Box-Jenkins. That's how we call it, Box-Jenkins methodologies. And here we have different models. We have AR, which is autoregressive models. We have MA, moving average. We have ARMA, ARIMA, and SARIMA. And they are uh, methods that use the structure of the time series to make predictions of the future values. They check whether previous observations are correlated with future values. So for this, we will go over the HCF, PACF plots, autocorrelation function, and partial autocorrelation function to be able to define which of these methods, the AR, AM, AMA, ARMA, or ARIMA, should be used. And the third category of methods will be more like machine learning models. And we'll use here from our previous classes, remember, random forest, neural networks. Like most of these algorithms, they have a version for time series. There are, of course, some key differences, especially when we're doing the cross validation. In the case of regression and classification, you can just split your data randomly, it doesn't matter. But in the case of time series, the order matters. So you need to keep in mind that because you cannot just split your data randomly. You need to ensure that they follow the sequence, right? Otherwise, your model is going to be a mess. Okay, so this was our introduction just to define time series, the key elements, why this is important for companies because every single business, regardless the industry, they need to make predictions, they need forecasts. That's why time series they are really important, right? Because this is key to start, different processes in real life. Okay, so this is everything for now. I'll see you in our next lecture.